Oh, good morning, and it is Tuesday morning, and we are trying to do the writing compounds worksheet here, okay? And so, first of all, the first top of the page is just to help you out. If you remember this periodic table, we said that atoms in this column have one electron in their outside layer, and they get rid of it because it's easier to get rid of one than to fill it up, which would take 7. So they are going to get rid of an electron, which gives them a +1 charge. This column, all the atoms in this one have 2 electrons in their outside layer. They could either gain 6 to fill it up to 8, or they could get rid of 2. And then, like us, they want to do the easiest thing, so they have a +2 charge. All right, then we swap over here to the other side, skip the middle for right now. And over here, these atoms all have 3 electrons on their outside layer. So if we have 1, 2, very good. Let me make the other one up here again. 3. Okay, so they either gain 5 to fill it up or get rid of 3. It's easier to get rid of 3, which gives them a +3. All right, and the next column, they have 4, which is kind of interesting because if 4, you would have to gain 4 more to fill it up, or you could get rid of those 4 to get rid of it. So they can either be +4 or -4 if they're in that column. All right, now the next one have 5 electrons. Now they only have to gain 3 more to fill it up, or they could get rid of 5. Well, it's less work to get rid to gain 3. So if they get 3 more negative electrons to fill up their layer, that would give them a -3 charge. All right, the next column, if you remember, has 6. So they only need 2 more to fill it up, or they'd have to get rid of all 6. So they generally tend to gain 2 more, which makes them have a -2 charge. Okay, the next column has 7. All right, which means it only needs 1 more electron to fill up its first row. So it's easier to gain 1 more than to get rid of 7. So it's just going to gain 1, which makes it a -1. And then the last column, the noble gases, have 8 already. So they're full. They don't need to add any more or get rid of any or anything. They're just happy the way they are. So they have no charge. And this is why they don't react with anything. In order to react, we need to put a positive, one of these, with a negative. And that way they will stick to each other because opposites attract. Positive and negative charges attract each other. So to make a compound, to stick stuff together, we need to be able to have a positive and a negative. Okay? Now, so since they have a neutral charge, they don't want to stick with anything. And that's one of the reasons these were not discovered for a long time. They don't react with anything. They're just gases that float around in the air. And so no one knew they were there, basically, because they didn't react with anything or do anything. All right. Now let's go back to these middle ones here. These middle ones are the transition metals. All right. So these are the transition metals. All right. And they're going to be positive, but they can have various charges, okay? They're not all the same. It gets kind of complicated, so we're not going to get into that. Not as simple as these others where they're either filling in the outside row or getting rid of it. All right, so say, for example, you had iron. You could have iron with a +1 charge. All right, or a +2 charge, or a +3 charge, or a +4 charge. So when we write it, we put it in Roman numerals, the number in parentheses. Iron 1 in Roman numerals would mean that it has a +1 charge. Okay, so if there's a 2, Roman numeral 2, that would mean it has a 2 charge. If there's 3 I's in a row, that would be a +3 charge, or IV, which would be 4. Okay, so iron might have different charges, and based on that, we have to, that when they tell you the name of the compound, they would have to tell you if it's iron 1 or iron 2 or iron 3 or iron 4. And that's true of all of these: iron, cobalt, copper, nickel, zinc, silver, lead, all these different ones that are in this middle area. Even over here underneath the stair step, if they're metals, they still will usually tell you what their charge is because they can have multiple charges. All right? All right, so now let's look at writing some of these compounds. All right, first of all, we need to figure out the symbol. So if we have sodium oxygen are going to be combined together. We need to write the symbol for sodium, which is, that's right, Na. Okay, and we're going to add that to oxygen, which is O. All right. And we want to stick them together. But the question is, how many of them will it take to go together? How many sodium atoms does it take to balance out with the oxygen atoms? Okay, well, if we look in our chart up here, Na, or sodium, is in this first column. So it has a +1 charge. +1. Okay, oxygen, on the other hand, is in this column where it's a -2. All right, if we stick these together, just one sodium and one oxygen, all right, they are not going to have the same charge. They're not going to be neutral. And to be a compound, we need to put two chemicals together, and there needs to be no positives or no negatives. They need to cancel each other out. All right, so what we do is we take this number times sodiums, and we put it down here for the sodium. So that means there's going to be 2 sodiums. And we can use the little subscript button up here to put 2. Then hit it again to get back to normal. Okay? And then we put oxygen atoms. We're going to multiply it times the exponent over here, which is 1. So it's going to be 1. If there's one oxygen, do we need to put a little 1 down there? No. Okay? If there's no number, that means there is one. So the formula for sodium plus oxygen is going to be Na2 oxygen, because 2 times a -1, each sodium is a -1 or positive 1. So 2 positive ones make +2. 1 -2 makes -2. +2 and -2 cancel each other out, and we have a neutral compound. Okay. Now the other thing I want you to do on this one is to write the name of the compound. Okay. And so this one is going to be sodium. All right. Always write the name of the first element, and oxygen by itself means you're going to put IDE on it, so it's going to be oxide, sodium oxide. All right. Yeah. All right, and that's how you would do these other ones here. Aluminum and fluorine, you look them up on the chart, see what their charges are. Whatever the charge is, put that number on the opposite one, kind of like cross multiply, and then you will get the compound. And then name the compound once you get over here to the other side. Okay? All right, but let's get down to number 4. Number 4 has something a little different. It has calcium, and it has something called sulfate. Okay? We've talked about sulfate. Sulfate means it's sulfur with an oxygen stuck on. In fact, it's SO4. Okay, so what this is one sulfur atom, boom, with, an oxygen, and an oxygen, and one more oxygen, and these oxygens are all attached to it. Okay, so this is a package deal. They all go together. All right, and here's the deal, is that they have a total charge of -2. These are called polyatomic ions. Because they're ions, they have charges, but they have more than one atom. Poly means many, atom, atomic means atom, so they have many atoms. So in this case, we have 5 atoms that are all stuck together, and this whole little mess here goes together, and it has a charge of -2. Okay, we're not going to worry about the why it has a -2 charge right now. Just go with that. It has a -2. All right, but when we write it as SO4. Okay, and we can't change the 4 oxygens. We can't change the number of sulfurs. Okay, this is a package deal. So if we need to put more than one of them, we are going to put a parentheses around it and then put a little number out here, say a 2, and that means we need 2 of all that's inside of there. okay? So let's go look at an example down here. All right, we're going to have, I'm going to click over here in text box. All right, we have calcium. So first of all, we need to know the symbol for calcium, which is Ca, that's right. All right, and if we go up here and look at calcium, calcium is in the second column, so it is a +2 charge. All right. So we're going to hit our superscript up here. I'm going to hit that, and we're going to say that it's +2. All right, and I hit it again to get back to normal. All right, I'm going to add that to sulfate, which we know is SO, do the little underscore here, 4. Okay, as sulfate equals, or a little arrow here, so this is on the other side of the equation, what are we going to have? Well, we're going to have calcium, and we're going to have SO4. The question is, how many of each of these? Well, we say calcium has a +2 charge. Turns out sulfate, if you remember, we'll go look up here. Sulfate, SO4, all that together has a -2 charge. All right. So if that one has a -2 charge, all right, then we put them together, -2 + 2. Do we need to make any adjustments? No. +2 - 2 cancels out. So our name is just CaSO4, and the name of that compound would be, well, we write the name of the first one, calcium, and then sulfur with an oxygen is going to be sulfate, which is what we said over here on the side. So this is just going to be calcium sulfate. All right, now this is measurement error again, and I have pre-done this one a little bit to get us going a little faster. Okay, first of all, notice we have copper, but then in parentheses it has Roman numerals, so it is copper with a +2 charge. Okay, copper would normally be in the transition metals, so we know it's positive, but we don't know for sure which one, but they tell us that it is a +2 charge. Okay, we have phosphate, PO4, which has a -3 charge according to our polyatomic ion chart up here. All right, so we know we have a +2 and a +3. If we add these together, will they cancel each other out? No, they will not. So we're going to have to add some numbers here. Okay, and we can pretend like there's a little 1 down here at the bottom on each of these, one of these, one of those. Okay, 2 times 1 here means there's going to be cross multiply, so we're going to have 2 phosphates. All right, so we're going to put a little 2. Notice we put parentheses around the PO4 because it means we're having 2 of those phosphate groups total altogether. Okay, the copper, on the other hand, if we cross multiply, would be 3 times 1 down here. So that's going to give us a 3 down there. All right, so 3 times +2 for each one is going to give us a +6. Okay, and this one, 2 times a -3 is going to give us a -6. So we have a +6 and -6, and these will cancel each other out and make a happy compound and live happily ever after. How nice. Okay, then finally we're going to name it, so it's going to be copper. But notice we have to say copper 2 phosphate. Okay, because the number, the charge of it is part of the name. So we're going to say copper 2 phosphate. Okay, and then we have some other ones down here with other elements, and you will have to do them about the same way. All right, so what I'd like for you to do is try to answer all the rest of these and kind of write them out, type them out like we did here, put the elements and their charges, and then over here put what the compound would be when you put them together. All right, and then write the name off to the side. Remembering if it has a Roman numeral that needs to be part of the name. All right, I think that should do it. Hopefully that'll work well. If you have any questions, let me know. Send me an email, and we otherwise have an excellent day.